Today we are going to learn how to test to see if two functions are inverses of each other by composing them. Why? Well, that's the definition of two functions that are inverses of each other. There are two functions that when you compose them both ways, you end up getting x. So that's what we're going to do with these functions. We're going to compose them both ways and see if they equal x in order to determine if they are inverses of each other. First pair are two linear equations, 2x plus 3 and 1/2 x minus 3/2. Let's see if they're inverses of each other. So we're going to take g and we're going to stick it into x. It equals 2 times 1/2 x minus 3/2 plus 3. Alright, we would distribute the 2. We're going to get x minus 3 and then plus 3 on the outside, so it equals x. That's a good sign. We can't stop there. We need to do it the other way. So g of f of x equals. We're going to take 1/2 and we're going to substitute in 2x plus 3. And then we're going to subtract 3/2. Distribute the 1/2, we get x plus 3/2, and then the minus 3/2 from the outside, which equals x. So it checks out both ways. They are equal to x in both cases. So yes, they are inverses. Alrighty, let's check the second two. We have a cubic and a cube root function. So let's check this out by composing them. F of g of x would equal the cube root of x minus 2 cubed plus 2. Alrighty, unfortunately that's really about all we can do. We could expand this cubic if we want to. We're going to get a cubic in standard form, but it's not going to be a perfect cube, so we're kind of at a dead end. We can say right here that these are not inverses of each other. If you wanted to, just for fun, check to see if it works the other way as well. Let's see, we're going to take the cube root of x plus 2. We're going to subtract 2 from it and then cube it. But once again, we have no way of combining this, because this is under a cube root, this is not, and this is subtraction. There's no way to combine a root and a subtraction problem and cube it. If you wanted to, you could expand this out by making 3 of these things and then distributing, but you're not going to end up getting x. There's no way you're going to end up getting x. So these are not inverses as well. If it doesn't work one way, it shouldn't work the other way as well. So nope, sorry, these are not inverses of each other. And our final one is two rational functions. We want to test to see if these are inverses of each other. So let's start by taking g, putting it into f. This is going to end up being really fun. 1 over 3x plus 1 over x minus 3. Alright, how are we going to deal with that ugly thing? I think we're going to have to clear out the denominator of this fraction here. How are we going to do that? Well, we can multiply the top and the bottom both by x, because that ends up just being 1, so we're not changing the function, and it'll end up clearing this out. So let's do that. Multiply every term in the numerator by x, we just end up getting 1x. Multiply every term in the denominator by x. This would just become 3x plus 1, and then this would become negative 3x. So when we simplify that, 3x and negative 3x is 0, so we end up with x over 1, which is equal to x. Hey, that's a good sign. Alright, now we have to compose it the other way. Alright, so this is going to be, we're going to plug in 1 over x minus 3 into g. So we're going to get g of f, g of f of x is equal to 3 times 1 over x minus 3 plus 1 all over 1 over x minus 3. Once again, we have fractions within fractions, which are no good. Let's multiply everything by x minus 3. Alright, so we're going to end up with, I'm going to go into another sheet of paper. We're going to end up with 3, let me just make sure I get this right, plus x minus 3, all divided by 1. And to show you why, if I multiply this by x minus 3, this term right here, it'll reduce with the denominator. I'm just going to get 3. If I multiply this by x minus 3, it becomes x minus 3, 1x minus 3. If I multiply this by x minus 3, the x minus 3 over x minus 3 will reduce to 1, so we just get 1 in the denominator. So we end up with this. Anything over 1 is just itself, so this would be 3 plus x minus 3, and the 3 and the 3 add to 0, so we just get x. That checks out. So notice, this gave me x, this way gave me x. So we can say that yes, they are indeed inverses of each other. And that's how you test using composition to see if two functions are inverses of each other.